Covalent bond part 1. The reactivity of an element depends on the number of valence electrons and on the tendency of an element to attain a completely filled outer shell. The atomic number of carbon is 6 and its electronic configuration is 2, 4. So carbon has 4 valence electrons, which means carbon has 4 electrons in its outermost shell. Now, to complete its outermost shell, it could gain 4 electrons forming C4-, but it would be difficult for the nucleus with 6 protons to hold on to 10 electrons, that is 4 extra electrons. Or it could lose 4 electrons, forming C4+. But it would require a huge amount of energy to remove the electrons, leaving behind a carbon with 6 protons in its nucleus holding on to just 2 electrons. So carbon could neither gain nor lose 4 electrons. Carbon overcomes this problem by sharing its valence electrons with other atoms of carbon or with atoms of other elements. Such bonds which are formed by the sharing of an electron pair between 2 atoms are known as covalent bonds. Part 2. The bonds which are formed by the sharing of an electron pair between 2 atoms are known as covalent bonds. Similar is the bonding in chlorine molecule. A single bond is represented by a line between the 2 atoms. Oxygen has 6 valence electrons, that is, 6 electrons in its L shell. So, it requires 2 more electrons to complete its octet. So, each atom of oxygen shares 2 electrons with another atom of oxygen to form oxygen molecule. The bonds formed by the sharing of 2 pairs of electrons are called double bond. The shared electrons belong to outer shells of both the atoms and enable both the atoms to attain noble gas configuration. The simplest molecule formed in this manner is that of hydrogen. The atomic number of hydrogen is 1, so its electronic configuration is 1 and the number of electrons in outermost shell, that is, in K shell, is 1. It requires just 1 electron to complete its duplet. In this case, 2 hydrogen atoms share their electrons to form a molecule of hydrogen H2. The bond formed by sharing of 1 pair of electrons is called single covalent bond. Similarly, nitrogen has 5 valence electrons in its outermost shell. In order to attain octet, each nitrogen atom in a molecule of nitrogen contributes 3 electrons, giving rise to 3 shared pair of electrons, forming triple covalent bond. Covalently bonded molecules have strong bonds within the molecules, but intermolecular forces are small. So they have low melting and boiling points. Since the electrons are shared between atoms and no charged particles are formed, such covalent compounds are generally poor conductors of electricity. Some other examples of compounds with covalent bonds are methane and ammonia. The element carbon occurs in different forms in nature with widely varying physical properties. These forms of carbon are called as allotropes of carbon. Diamond and graphite are the allotropes of carbon. Both are formed by carbon atoms, but the difference lies in the manner in which the carbon atoms are bonded to one another. In diamond, each carbon atom is bonded to 4 other carbon atoms, forming a rigid 3D structure. In graphite, each carbon atom is bonded to 3 other carbon atoms in the same plane, forming layers of hexagonal arrays. These layers of hexagonal arrays are placed one above the other. Due to this difference in the structure of diamond and graphite, they have very different physical properties, even though their chemical properties are same. For example, 1. Diamond is the hardest substance, while graphite is smooth and slippery. 2. Diamond is a poor conductor of electricity, and graphite is a good conductor of electricity. Fullerenes are another class of carbon allotropes which have carbon atoms arranged in the shape of a football. Carbon compounds. We know that valency of carbon is 4 and it forms bonds by sharing electrons with other carbon atom or any other element. Carbon can form bond with other carbon atoms by sharing one pair of electrons or 2 pair of electrons or 3 pair of electrons. Compounds in which carbon atom forms single bond by sharing one pair of electrons with other carbon atom are called saturated compounds. Example, ethane CH. In order to arrive at the structure of ethane or any other simple carbon compound, the first step is to link the carbon atoms together with a single bond. The 3 valencies of each carbon atoms are unsatisfied, so each is bonded with the hydrogen atoms. Similarly, you can draw the structure of propane C3H8. Such compounds of hydrogen and carbon are normally not very reactive and are thus known as saturated compounds. Compounds in which carbon atoms contain 2 or 3 covalent bonds between at least one pair of carbon atoms is called unsaturated compound. Example, in order to arrive at the structure of ethane C2H4, first we link the carbon atoms together with single bond. 3 valences of each carbon atom remains unsatisfied. Each carbon atom gets 2 hydrogen atoms. We see that 1 valency per carbon remains unsatisfied. This can be satisfied only if there is a double bond between 2 carbon atoms. Similarly, in order to arrive at the structure of ethyne C2H2, first step is to link 2 carbon atoms with single bond. Each carbon gets 1 hydrogen and 2 valences per carbon atom remains unsatisfied. This can be satisfied if there is a triple bond between two carbons. Such compounds having double, triple bonds between the carbon atoms are more reactive as they are unsaturated.